Okay, here's your notes for the lesson that you're going to do. You might want to print this out on the PDF if you don't have it, so you have it right in front of you. So there's three kind of exercises students are going to be doing. Now, in the day before, what I'll have shown them is a polynomial graph with the equation graph. They'll have had to interpret this information from the graph. But now it says for each polynomial function standard form, find the following without a graph. So these are kind of properties that they'll need to know. They'll have to fill the degree out, the number of terms, the leading coefficients, the y-intercept, the end behavior of the graph, and then the number of possible turning points. It doesn't mean that's how many there are, but that's possible. So it's really just some algorithms and rules. So first thing they're going to do, f of x, explain to them that it's a function instead of an equation. It's just instead of y, you have function of x. I mean, it serves the same purpose as a y. It's the output of a function. Now, they're going to need to rewrite a lot of these into the proper formation. So again, we have -4, that's an x term, 9 is your constant term, and 2x third is your x third term. So we need the x third term first, so positive 2x cubed. There is no x squared term. Then the x, -4x, and the constant should always be placed last. So that's where we're at there. And now we start looking at our key features. So degree. Degree, if you have x third, if that's your highest degree, we're going to put that, and the answer is just 3. Okay, so 3. Number of terms, 1, 2, 3, that we've explained what terms are before. Leading coefficient, what's ever in front of the highest x degree, it's 2, so positive 2. Y-intercept, now explain to them that the y-intercept is really a coordinate, and we set the x equal to 0. So if this x is 0 and this x is 0, these are out, but you'd still have a 9 that's not multiplied by x, so the output would be 9. So 0, 9. We don't get into x-intercepts, finding them. We did them yesterday on the graph, but they won't have to know them today because I've only taught them how to factor a quadratic, okay, meaning x squared. I've not taught them how to factor a higher order equation, a polynomial. Okay, end behavior. Now, this is going to look gibberish to them if they don't write something down. X being positive infinity is a funny way of just saying the right side of the graph, okay? And x negative infinity is just the left side. So f of x basically means what's the graph doing? Is it going up or down? Okay, so to find the right side, they have to look at the leading coefficient. If that is positive, which it is, then that'll go up. So that if they put up, please make them put comma positive infinity. Okay, so on the left side, now is where you look at the degree. If the degree is odd, that means the end behaviors have to be the opposite. So if it's going up on the right side, it's got to go down on the left side, so that has to be negative infinity. Okay. Number of turning points, explain to them that the degree is x third, so there's always one less possible turning point. The number of possible turning points would be 2, so it's always one less than 3. Or whatever the degree would be. That doesn't mean there necessarily are. That means possible, highest amount possible. Okay, next one. Write it in the proper order. So 2x, that's your x fourth is your, and then you've got your constant and your x third, okay? Okay, so x fourth is your highest, -3x to the fourth. X third, -5x to the third, okay? There is no x second, so that it skips over that degree, and then x would be plus 2x, and the constant's plus 6. Okay, so the degree, x to the fourth, which means our degree is 4. Now it's even this time, so the end behaviors will be the same. Number of terms, 1, 2, 3, 4. Leading coefficients, -3. The y-intercept, we just put the x to 0, so that means this, and this would 0 out. Then you got 6. And behavior, again, this x approaches positive infinity is where they say the right side of the graph, and this is the left side. Okay, so on the right side of the graph, well, we look at the leading coefficient. Again, or you can look at the first term. If that's a negative, then that's going to go down on the right, which means negative infinity. Now this time the degree is even, so their end behaviors have to be the same. So if it's going to go down on the right, it's also going to go down on the left. So negative infinity on both. Both the functions go to negative infinity on the right and the left. Okay, the degree here, x to the fifth. So it means the degree, oh, whoops, I forgot to write the proper order. And this one's kind of different. You got x fifth, they can put a 1 as a coefficient if they want. 2x to the sixth, that's a x6, x fourth. Another x6, so we have two, those are called like terms since they're both x to the sixth, x to the third. Okay, so x to the sixth is your highest, but you have two of them, so you have to combine some. Make sure they don't add the exponents. You'll have some that think you have to do that. It's still x6. You just add and combine 2 plus negative 8. So since we have two of these, we keep the degree at x6, but we add 2 plus negative 8. That's negative 6. Okay, x fifth, I have 1, so plus 1x to the fifth. X to the fourth, we have negative 3. That's negative 3x to the fourth. X to the third, we got positive 4x to the third. And there is no x second, there's no x, and there's no constant, okay? So it's just going to be stop at x to the third. Okay, so the degree is x to the sixth. It wasn't x to the fifth. Number of terms, 1, 2, 3, 4. Okay, so 4 terms. Leading coefficient is negative 6. And the y-intercept, well, if we set the x to 0, that means this, 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 and this, they'd all go to 0, so there's nothing, no constants, so that means 0, 0. The origin is going to be your y-intercept. Okay, then the right side and the left side. Okay, so our leading coefficient, or the very first term's negative. Well, that means on the right side, the graph goes down, which means negative infinity. Okay, now you look at the degree. If you have an even degree, which x to the 6 is an even degree, that means the end behaviors have to be the same. So if they're on the right side, the graph goes negative infinity, then the left side, it's also going to be negative infinity. Okay, then the last one. So first off, do we need to sometimes you don't even need to rewrite it. X fifth, x fourth, x third, x second, x constant. So none of them are like terms, and they're already in the proper order. X fifth, x fourth, x third, x second, x followed by the constants. So we don't have to reorder it. So the degree is x to the power of 5. So again, the degree is going to be 5. Number of terms, 1, 2, 3, 4, 5, 6 is 6 terms. Leading coefficient would be a 1, positive 1. And the y-intercept, we'd put 0. And then those would all go to 0, but you'd still have to add 18 to your 0, so it'd be positive 18. Okay, so right and left. Okay, so on the right side, so the leading coefficient's positive. That means on the right side it goes positive infinity. Okay, then negative infinity on the left side. That means the left side. So the degree is odd. That means that the end behaviors have to go in opposite directions. So since this one's going up, positive infinity, this one has to go down, which would be negative infinity. Okay, and that's the first exercise. All right, now in the next section of the assignment, it says graph the following polynomial functions. The turning points and x-intercepts will be approximated but not exact. That means we're not really going to worry too much about those when we have to actually graph it ourselves. Use the degree and leading coefficients to determine end behavior. Make sure that that's important, the end behavior. Okay, so here's the first function. Part A, you're graphing the function. And this is how you're going to graph it. That will be set up for them on the first example, but they will have to set this up on the second, just to acclimate. And then there's a part B, but let's get the function graph first. So the function is f of x equals negative 0.5 x to the fourth plus 3x to the second plus 2. That 9 there means the x goes to 9. So the coordinates on the x, I labeled it by 1s, and the y went by 2s. or the f of x, I should say. Okay, so pretty much with a polynomial function, your best bet is to just do input, output, and you can pick as many as you can, but so it doesn't get laborious. Let's just go input integers, -3, -2, -1, 0, 1, 2, 3. Now one thing, the 0 should be obvious. The 0 means you put all these x's to 0, every single one of them. So if that's 0, that's gone. That would be 0, but you'd still have this constant 2. So you can go ahead and put f of 0 equals 2, and they can go graph that. That is your y-intercept point. So the 0 should be pretty straightforward. Now they are going to have these kinds of calculators. So f of -3, that means every x is replaced with -3 on the right side of the function. Okay, so -0.5. And then I usually have them put in a parentheses, and then -3, close the parentheses. And then power 4 is the upside down V key. We call it the caret key, 4. And then +3. I don't like doing order of operations with input outputs of functions. I just like to make it so they don't get lost in the grind. Just use a calculator. +3. Then I get another x, so I again replace that with -3. It's x to the second. They can hit the caret button 2, or they can hit the x2 key if it's to the second power, and then +2. -11.5. Okay, so we go -3, -11.5, between -10 and -12. Okay, now what I tell them to do is not clear their calculator, keep it up. I tell them to hit the up key on the compass, and then the negative, instead of -3, now I want -2 into the function for the x's here and here. So we'll keep the negative, we just need 2, and just use a compass to guide it, and then 2. It's just order of operations. That's the only x's you had, so hit output, that should be 6. So make sure you mention it's positive, so -2, +6. Okay, -1 in for the x's, so. $4.5. Okay, so -1, positive 4.5, so that's up. So it's between 4 and 6. Just kind of sketch it. Explain to them this is a sketch. It's not a perfect exact one. Okay, now we got the 0. Now here's what we need to do on the positives. So we had -1. Now to get +1, all they got to do is hit their calculator and just put the mouse over the negative and hit DEL, delete. Okay, so there's -1 again. Just go over the negative, hit DEL, delete. Okay, 4.5. Now you're going to have some people say, well, does the negative input and the positive input have the same output? And you need to explain no at that point, that they don't have that, okay? That's just a coincidence on this particular function. Okay, then 2. And I'm not going to call out during class and correct you, okay? That's not what I should do, okay? 6. Better graph these. So go forward 1. So input 1, 4.5. 2, 6. So 2, and then 6. And then 3. Okay. And I can make transparencies of the graph paper if you want to work on the overhead. Okay. But if you'd rather sketch it on the board, that's fine too. So 3 and then -11.5 between -10 and 12. Now here's what they're going to need to do. Okay. So they want to start with the first output they got. Then to get to the 6, they'd have to increase. Then to get to the 4.5, they decrease. To get to the 2, they decrease further. But then to get to the 4.5, they'd increase. Then to 6, increase. But then to -11.5, they would decrease. Now, this is the last part, but they have to get the end behavior correct. Okay? On the right side, this is right. Okay? And this is positive infinity. they need to look at this very first term. If it is negative, okay, that means it has to go down to the right. They have to have an arrow going down. Now, then they circle the exponent, and that's even. So if they're even, they have to do the same end behavior on each side. So if we're going down on the right, we actually have to go down on the left, and then we're done. Okay? Okay, now find the rate of change over the interval, 0, 3. What that means is they're just going to make two coordinates. They can either go x1, fx1. They can also go x1, y1, or x2, fx2. Okay, so 0, 3, they're going to put a 0 and 3 and look those up. So when we did 0, we got 2. And when we did the input 3, we got negative 11.5. That's all they have to do is they don't have to recalculate it. Okay, explain that the rate of change is similar to finding a slope. It just means what does the y do? It's basically the change of two different quantities, in this case an x quantity and an fx quantity, compare. So basically what they need to do is find the difference of the two outputs, okay? Take the second output minus the first output. So it's going to be negative 11.5, similar to finding the slope. Almost exactly the same thing, y2 minus y1, x2 minus x1. So we're going to take negative 11.5 minus 2. That's going to be negative 13.5. Then in the bottom, they have to subtract the inputs. 3 minus 0 is 3, and then they just divide that. It divides to negative 4.5. And then you might want to explain that means the output changes by negative 4.5 per every x input, 1 unit of x input at that interval. So 0, 3. Okay, I'll do a couple more. I would do a couple more graphs. Okay. So f of x equals x is 6 plus 18x is second plus 10x plus 1. Sorry about my crappy writing. That is a plus 1. Okay, so what they're going to do is the same thing, but they set it up. Just f negative 3, f negative 2, f negative 1, f of 0, f of positive 1, f of 2, f of 3. Okay, it's not that hard to write that out for them. Now they should be calculating the f of 0 first. That should be obvious. So if all these x's are 0, that means f of x would equal the 1 at the end. Okay, so 0, 1. Now we had to go by 5, so 1's just a little bit. And I've scaled the graphs for them. Okay. And again, if you want me to make the transparencies, I can turn the overhead on and all that for you. Okay. You will be in my class, I think, the period before you teach, so it's... Okay, so now you're going to put negative 3 in for all the x's. If they freak out about the x here not having a coefficient, they can always put a 1. Okay, so all the f of negative 3 means every x on the right turns to negative 3. So 1 and then negative 3 caret 5 plus 18 parentheses negative 3. And then it's to the second, so they can hit x2 plus 10 parentheses negative 3 plus 1, okay? Negative 110, they're going to be like, what? Yeah, it's right. It's just we're not going to be able to graph it, and we'll show, and you'll explain how you're going to graph it then at the end. So then you want negative 2, because they're going to be like, what, the way he scaled it, we can't get to that. 21. Okay, negative 1. And explain over and over that it's a sketch. It's not going to be exact. Okay, 8. Okay, we got our 0 done. Now they just have to go delete the negative, and now they want positive 1. That's how I've taught them to do input-outputs for functions on this calculator. Okay, so 30. Now we want 2. Okay, 125, and now we want the 3 x's to go to 3, so we got to put a 3 in 3 different places. $436, okay. So there's your input outputs. Now explain to them that -3, okay, -110. Now it needs to go down. If it's not on the graph, just make a point right directly below the -3 off the graph, okay. -2, +21. So -2, +21, it really goes up. Okay, -1, 8. So -1, 8, +8. 0, 1, so 130. And then 2, 125. 2, just go up off the graph. Don't worry about how high. 3, 436. So 3, just go higher. It's a sketch. Okay, so we start there off the graph. Now, obviously, to 21, it would have to go really up, okay? Then you go down to 8, down further to 1, up further to up to 30, so there's a turning point, to 125, and then 436, okay? Now, it's not going to look beautiful, so I would have to do the same thing in your position. Okay, so the right side. Well, the right side positive term means it just goes positive up. Just fit an up arrow right there. Now, since the degree is odd, they have to do the opposite. And, you know, if we're going up on the right, left to go down. Okay, that's all that is. Average rate of change over the interval. So what they're going to do is they're going to put 0 in the first coordinate, 2 in the second. So we see the 0 was 1. And then we see the +2 is 125. Then they take 125 minus 1, subtract the 2 inputs, the second input minus the first one, that's 124. Then the 2 inputs, 2 minus 0 is 2, and you divide 124 by 2, and that is going to be 62. So 62 is your rate of change. That means over this interval, every time the x changes by 1, the y changes on average by 62. Okay, next one. And this is the last graphing you'll do with them. F of x equals 2x cubed minus x squared minus 13x minus 6. So f of -3, f of -2, f of -1, f of 0, f of 1, f of 2, and f of 3. Okay, let's get the 0 down, -6. So plot 0, -6 between the -5, the -10. Make sure you watch this and know what I've scaled the axis by and take a look at the packets. Okay, so 2 and then -3 to the power of 3, so caret 3 minus 1, and then the x there, -3 again, but it's to the power of 2, so they can hit caret 2 or x2, minus 13, and then -3 again. So all the x, this means every x goes to -3. Okay, the input was -3 and the output was -30. Then we want all 3 of the x's to go to -2, so we keep the negative and just go over the 3's with 2's. Should be 3 of them. 3 x's means there's 3 places where you have to change the input. 0. Okay, then -1. -4. Okay, then to get from -1 to +1, they can just delete the negatives. So DEL, DEL, DEL. Okay, so -18. Now we want 2 in, so in the 3 x's we got to put 1's to 2's. -20 and then 3. 0. Okay. Just want to double check that. Okay, so I think we can get them all this time on the actual coordinate plane. So -3, -30, -2, 0. Explain that that's an x-intercept. I have not taught them how to factor these higher ordered ones yet. Okay, -1, 4. 1, -18, so 1, -18. 2, negative 20, so 2, negative 20, then 3, 0. Okay, so again, from negative 30 to 0, it goes up. From 0 to 4, it keeps increasing, but then 4 to negative 6, it drops down. So that's a local maximum. But they don't need to determine what it is. So 1, negative 18, so 1, negative 18. I might do that with them later. 2, negative 20. Then it goes up to 0. So since our first term, our leading coefficient's positive, it's got to go up to the right. And since you got an odd degree, they have to have the opposite end behavior. So on the right it goes up, on the left it goes down. Okay, find the average rate of change over the interval. So explain that you're going to look up your input. That's what the interval means, negative 2, 2. So you look up those inputs, 0, and then 2 is negative 20. Okay. So negative 20 minus 0 is negative 20. 2 minus negative 2 is going to be 4. So that's an average rate of change of negative 5. That means from negative 2 to 2, it went down an average of 5 units, the output did, per X interval. Okay, then they'll have an application, but it's really easy. It says, an analyst for a new company used the first 3 years of revenue for the company. The analyst predicts the function f of x equals 10x fourth minus 7x cubed plus 8x squared minus 6x plus 70 will give the revenue after x years. Should the CEO expect the company to be successful? Question mark. Explain. You don't have to do much, they won't have to do much explanation, okay? Basically what they need to do is predict the future, which would mean explain that x won't go to negative infinity because yours is x and x can't be a negative, so negative domains would not be applicable. So I just need to determine the end behavior of when x approaches positive infinity, which would mean the right side of the graph, okay? Okay, now we have a positive leading coefficient, so that means the f of x, okay, will go up. So f of x, or y if they really want to put that, will approach positive infinity as well. So if it's approaching positive infinity, yeah, it's going to be successful because it keeps on going up. So we want to answer the question yes. And that right there is basically the explanation they need to give. Okay. How about if the function is f of x equals negative 6x cubed plus 4x squared plus 11x minus 12? Well, again, x would just go to positive infinity on the right. It wouldn't go to the left beyond the 0, so there would be no negative infinity. So it'd just be positive because they're talking about a real-life problem. If x is years, we cannot have negative years. So x you would just look at what it's doing on the right side as the years go on and on and on and on and get deeper, deeper, deeper. What happens? But this time, our leading coefficient's negative. So that means on the right side of the graph, the f of x is going to be going negative infinity. So it's going to be going down. So that would mean it just goes infinitely down. So the profit's plummeting. So the answer would be no. Okay? The profit would be in the hole. Explain to them that, yeah, you can't have negative years, but you can have a negative profit because you're losing money, or negative revenue means you're losing money. Okay?